In this video, we'll be talking about the basics of computer vision. Here, we're going to talk about a basic object tracking task. So suppose your robot is in a world where there are a couple of simple objects in front of it, like this blue circle and this red triangle. And what you want to do is be able to track this blue circle. In other words, you want to move up to it, face it right in the center of your field of vision, and maybe stay a certain distance away from it, and maybe follow it as it moves along. One of the ways you can do this is through computer vision, or the idea of using images to make some kind of insights about the world. Say for this super simple environment, your color image looks like this. You see you have a green background, the blue circle, and the red triangle. If you want to keep that circle in the center of your field of view, you're going to have to turn your robot left a little bit. But what about the distance part? What if you need to move forward or backwards? How would you do that? One way of using the color image might be if you know that the real object is a certain size and the one on the image is a certain size, you can make some kind of correspondence with information about the image to then figure out how far away your object actually is. But again, that requires you to know the size of the object beforehand, which you don't always know. Another option is to use depth images, and these are images that you can get from sensors that use more than just a single camera. There is, for example, stereo camera, which is two cameras that together can figure out how far away objects are. Or, like the sensor you see here, the Kinect, it's a combination of a color camera and an infrared depth sensor. Here you'll get an image that tells you how far away objects are, which you can then use to figure out whether you should move forward or backwards to keep your object at a certain depth. So let's look at some of this in MATLAB. We're going to be working mainly on the vision folder today, and I'm going to go right to this process image script that we have. So the first thing that I'm going to do is just connect to the robot and create some subscribers to the color and the depth image. Now, I'm going to put an object in front of the camera, and then you'll see that in just a second, and you see me holding up this object in front of my field of view. So you see I have a sheet of paper with a blue circle that's on the left, and on the right side, I have my depth camera, which is giving me an indication of how far away things are. If we dig into this a little bit, I do want to look at my workspace for just a second on the right side of the screen and look at those two images that I just received. So if I look at the depth image, I just double click it, you see that this is a matrix of size 480 by 640, and it has certain values like zeros, or maybe if I keep scrolling, there might be some non-zero values at some point, which denotes the depth of the object probably in millimeters, I would say. Similarly, if we look at the other image, then you see this one, you can't see it here, but it's a 480 by 640 by 3 value. And this has to do with the fact that the size of the image is 480 by 640 pixels, and 3 denotes the color channels of the image, like red, green, blue. Now that we received the image, maybe one thing we want to do is talk about processing of color. So I'm going to go to my apps section here in MATLAB, and I will select the color thresholder app. Once it is available, I'm just going to load an image from the workspace, which is my exact color image. And then here you see it gives me the option to choose between different color spaces like red, green, blue, hue, saturation, value, and other popular color spaces. I'm just going to stay with the RGB space for now. And you see, once that I've loaded up this image, I get these sliders that I can use to basically filter my image by the type of color that I care about. So in my case, I care about keeping that blue circle as the only thing in my image so that I can then process it out. I can do this by following the sliders, as you see here, or I can actually use this polygon option and just select the region of interest that I care about as far as the blue object. And maybe it'll look something like this. So once I'm done, I get something that gives me what I think is a good discrimination between the background and the object that I care about. Once I'm done here, I can actually export the processed thresholds into a function so that this gives me a MATLAB function that I can use to filter out my image by its red, green, and blue values. So I can directly use this for the rest of my image processing. What I've done already is I've created a couple of functions in the same way called create mask blue and create mask red that you see over here. So I'll be using those to process my image. So here I've created a couple functions that just make this easier for me, like called detect object and get object depth. So I want to look through at least the detect object function to show you what this does. I'm going to open this function. So this uses a combination of that color thresholding functionality that I gave, and once you have that image, you run it through what is known as blob detection, or being able to highlight sections of your image that all have the same property, in this case that they're all blue. And I'll show you in just a second what this looks like. I maybe put a debug breakpoint here, and then we can run through this function. So here, under process image, I'm going to run this particular section of code, and that gets me into my first breakpoint. So all that I've done so far is I took my raw image and then I ran it through the create mask blue function. If I just show that black and white image mask that was created, you see that this is what my threshold image looks like. It correctly detects a circle as a white object, but there's a lot of noise around it. For example, you see that the bottom of the sheet of paper still is picked up as blue, which means that either we need to make sure we have better lighting or do some better thresholding to fix this. But let's suppose that this is okay for now. Once I have this image, that's when we run this through the blob detection algorithm. So I'll step through in MATLAB. And now I get a list of areas, centroids, bounding boxes, and major axes. These are all properties of the size of whatever blobs are detected. And again, just to make sure, a blob in this case, the biggest blob would be this whole section of white that is all together. So if you look at it, for example, areas contains a vector of two things. So one of the areas is 300 pixels squared, and the other one is 44,000 pixels squared, which is probably the biggest one that we care about. Same for centroids. This gives me the location in the image of in pixels where those values are. And you see that if I try to kind of hone in on the center of this blob, then the value is somewhere around 300 to 40, which corresponds to one of the blobs that I'm seeing. Okay, so once I have that, I'm just going to continue on through the script. And you see my annotated image looks something like this. So it's not great. You see that the bounding box that it gave me isn't quite accurate, but it tells me that the size of whatever box came out here is 255 pixels. That's the major axis, so the diagonal of that rectangle. And that the depth, it thinks it's about 0.5 meters, and that's by averaging the depth of everything that it saw here, which again is not going to be accurate. So let's try this again, but by running this continuously on our images to see if it's better than just with one static image. So I'm going to open the vision task depth script, which is going to do everything in a loop. So it's going to do the image processing as well as some tracking to try and move the robot to a certain distance and to have the object centered in the field of view. To make things easier for me in debugging, I'm just going to quickly scroll down and set my velocity commands to 0. I'm just going to multiply them for now so that my robot doesn't move while I try to do all of this. Similarly, if I move this further away, then my depth is about 1 meter here. And again, it will decrease down to about 0.6 or 0.7. You see that once I move this closer, the depth values start getting strange because the sensor has a minimum range that it can honor. So really, you should be looking at things about at this distance. So I'll go back to the script and make sure that I send the velocities back to the original values. And now we can try out this tracking live. So another thing you can do with the depth camera is use it by itself. And here I'm going to show you that in a Simulink example. Under tasks, there's a model called depth follower, is a model that's controlled by a ROS parameter. So if you have this parameter as enabled follower to true or false, it will do the remaining of the following. So the idea is that this will use the depth camera to look for a person in front of it as just a blob of depth, and it will track it just like we saw with the color images. So moving forward or backwards to keep a certain depth, and then keeping the depth blob at its center. And you can see this in the Simulink model by the fact that we're subscribing to the depth image, doing some processing using MATLAB code, and then here we're doing some basic proportional control to track the linear and the angular speed. So let's see this model in action. The last thing I want to show you is point cloud processing, which is something else that you get with a depth camera. In addition to a separate color image and depth images, you can actually combine them both into a color and depth 3D point cloud. I'm going to connect to the robot and subscribe to the point cloud topic and just receive this particular point cloud. As you see here, I'm standing in front of the robot and I'm holding a book in front of me as well, and that's coming out to be a different depth. Everything else is just the background or the wall. So the idea is that I can process this and maybe filter out certain objects that I might be interested in detecting or manipulating by using the depth to kind of segment out the image. You can just run through the script to see some of the functions, but here's what you can get out of it. If you're smart about the distances that you choose, you can actually cluster the point clouds. So in this case, I've actually separated the wall, myself, and the book into 3 separate obstacles. So suppose that you wanted the robot to go pick up that book, you could now get this third cluster, the yellow one, and go to its location relative to the robot and manipulate it. So that's a couple of basics of computer vision. If you want to know more, you should check out our computer vision tutorials. And stay tuned for the next video where we'll talk about more vision-based topics.